So I've seen a lot of banks in Minecraft, and I've seen a lot of combination locks in Minecraft, but I haven't seen many banks that use combination locks. Now, I'm not just talking about a bank vault here that has a combination lock that lets you access it. No, today I'm going to try and create a multi-user system where each user can have a unique 4-digit PIN. They enter that PIN and it gives them access to their items. Now, before we get properly into this video, I want to remind you to subscribe. I'm going to be having videos like this redstone video coming out once every week, so make sure to subscribe so you don't miss those, and also the showcase for this contraption, which will be coming out in the future. So this system is going to work using item sorters, which I'm just building out here, and the item sorters will each have an individual item which will be renamed to a number. So when you enter your number, it will then insert the combination into a hopper, which is going to be locked with the 4 items in, and then it will unlock the first item. It will travel through, and depending which number it is, it will take a different amount of time to pass through the hoppers. So it will, if it's a 1, it will only take 1 like hopper transfer to get to here. If it's a 2, it will take 2, and if it's a 3, it will take 3. So the higher the number, the longer amount of time it will take for the item sorters to pulse. And then it will release the next items. So this means that each individual code will have a unique pulse pattern that corresponds to it, and so we can simply hook up a system that goes together with this pulse extender that pulses that exact pulse, and then it will turn off if the pulse signature doesn't match that that this is given. So only if you insert the correct combination will it work. So this is sort of the main circuit. And then I want to make each sort of module to add a combination small so that it can be easily expanded without increasing the size. So this will be the main bulk of the contraption that will give you the pulse sort of signature pattern. And then the other parts will hopefully be simple. So I've built this up. Of course, we're going to put the items in. And we're going to hook up our system so that it has this hopper locked until we get a pulse through this. And then it will unlock it. So I'm going to do that now, and then I'll cut back to you. So I've built the redstone up now, and I've filled in all of these hoppers with the items. As you can see, we've got 1, 2, 3, and I'm just going to put these hoppers back below now to start sucking out the items. And that goes all the way up to 9 up this end. And then I've simply hooked up a line so that when any of these item sorters trigger, that detects and it unlocks this hopper momentarily. So if we start out, we can put our code in. So let's say we put in 1, 2, 5, 9 as our code. Then when we press this here, so we've just got to trigger this observer for the first time, we should, get a unique signal of pulses here that corresponds to our code. So I've actually realized there's a flaw with this system in that these are dual edge circuits, these observers. So every time this powers on and off, it's going to power. So we need to get rid of this line, and we've actually got to replace it by a bunch of monostable circuits. So if we then try this again, so let's go 4, 7, 9, 6, and press our button, we should, in this line here, get a unique sort of code signal that corresponds to our item, and that works out quite well. So the 2 circuits we need to have now are the circuit that obviously takes our inputs from the button panel and corresponds them into the 4-digit code in this hopper here. I think I'll do that last. And the second component is going to be the decoders. So obviously we've got our signal code trace here, and we need to basically compare this against our actual code to check that it's correct. And if it's correct, we want to send a signal through that module. And if it's incorrect, then we don't. So effectively, we'll have a bunch of these over here. So we're going to need to build these up. And the idea I have for these is actually something by another YouTuber. And that YouTuber is Narcoleptic Frog. So I'll leave a link to his video down in the description, as well as his channel, where you can check out these minecart memory modules which he's created. And this is one on my screen right here. So this effectively allows us to create a series of pulses through this wire, just like this system over here, but it will be the same every time, and as you can see, it's a lot more compact. So in this top chest, well, in this bottom chest, we have a series of items. So actually what it will be is, for example, 8 blocks of quartz, then 4 diamond swords, then we can maybe have, I don't know, 2 slime blocks, and then another diamond sword, and then maybe a powered rail, and then another diamond sword. And this will create a series of pulses through this wire. So let's power it, and the two chests swap. And as you can see, this lamp will switch on at intervals. You can see it switches on, and then it switches off, and then it switches on, and then it switches off, and then it switches on. So we can control this depending on the items that are in this chest here. And that allows us to change the combination. So it's effectively this, but a lot more compact. And it's really, really superb. So it's effectively this, but a lot more compact, and you can't change what combinations entered every time. So effectively, you can build up a bunch of these next to each other. They're all pulse at the same time. And as long as the two combinations are the same, then everything is fine. So to do this, what we actually need to do is hook up the wires together so that if either of them powers when the other one is not powered, then our system resets and that combination is incorrect. And that is actually a fairly common circuit known as an XOR gate. So I found online a tutorial for a one-wide tileable XOR gate, and I've simply hooked that up to the contraption here. So this is the XOR gate. So any time that this signal, which is this signal on the glass here, which is going to be hooked up to this signal, does not match this signal coming from this comparator here, we will actually get output. So this torch will turn off. So we'll have another torch here which will turn on whenever the output is incorrect. So I'm then going to bring this across to here. So what we're going to have is a circuit like this one. So this is the input line. So when we enter our combination, this block will be pushed across over top of this observer. Now, if the combination is correct, this line will not pulse. So this piston will not push this block across, and it will remain above this observer. That means when the combination is finished entering, we can pulse this observer line, and that will allow this piston to pulse. But if we do happen to get an incorrect output, so say for example that we actually got an output through this line here when the other line didn't pulse, we'd actually get this piston to extend, and it will push the block so it's no longer above this observer, and when this line triggers, this piston does not extend. So that means the combination is incorrect. And what we can actually do is put a bunch of these modules next to one another, and they will not interfere. By the way, I'll leave a link to the XOR circuit that I used down in the description. I've actually modified the design slightly. I've replaced these comparators. I've replaced repeaters with comparators here, because comparators don't respond to a one-tick pulse. And that means that actually these inputs can be activated simultaneously, whereas before you had to offset them slightly. So that prevents that, because this top one actually receives a one-tick pulse through it if the inputs are activated together. But I fixed that, and I've also replaced some of the redstone wires by observers because I realised I would run them next to each other. So there we go. And I've also installed this top circuit here. So this line comes from when we initially power the circuit, and it powers these pistons to push it across. And then if the combination is incorrect, this piston will fire as you saw. So this has got a combination in 1 and then 3 and then 1, and this is incorrect. So this has pushed the block over. So when we power this line, this doesn't actually power through. So if I just grab some lamps, what we can do is place them on top of here. So when we power this line, this one powers because the block's there, and this one doesn't power because there's no block here. Now this is useful because this one hasn't actually powered because there's nothing in here, so the combination is actually nothing. And because we're not powering this line at all, 0 and 0, they match each other, so actually it's correct. So now what we need to do is link these circuits together. Obviously I haven't positioned them next to each other, but I can just fiddle the redstone wire so that it's correct. And I've also got to figure out like the right items so that it's correct. So that may take some working out. So I've connected the two modules together, and I've done some testing, and it seems like I need to make this much slower because they don't hook up at the same rate at the moment. So one item in this does not correspond to one item in this, which is strange because I feel like it should do, but it doesn't.
2 hours later.
It's been quite a while since the last clip, and that's because I've had some nightmares with the timing. So I have actually got it working now in this version over here, and as you can see it's massive, so I do plan on compacting it down in just a minute, but I'll walk you through what I've done first. So this is my original design, and it of course used the hoppers going across, and I thought the transfer rate of hoppers was consistent at 8 game ticks per hopper transfer, but it actually turns out that it is, for one, not consistent across the world. So it's locational. So sometimes it takes 7 game ticks, and sometimes it takes 8 game ticks. And also, transferring from entity up here to down there, and just across along with hoppers actually takes a different rate. And you can actually see this here. I've got 1 item in this chest here, and 1 item in this hopper here, and the game is running currently at 1 tick per second, so 20th of its regular speed. And if I flick this lever to unlock the hoppers, you can see the comparators both activate at the same time. But if we leave it a couple more game ticks, you actually see that they deactivate at different times, which is causing some problems. As you saw, this one deactivated before that one, even though the items were released at the same time. So that is why I had to change how I ran the circuit. This is the redstone, and although it looks like a lot of spaghetti wiring, it's actually quite simple. The first change is that I turn this hopper line into a line of droppers, and these droppers run on an 8 game tick clock. So this kind of simulates perfect hoppers, because actually hoppers are inconsistent with their item transfer rates between 7 and 8 game ticks, and using a dropper line running on a clock means it's always going to take 8 game ticks, which is the exact amount of time it takes for an item to be transferred in the minecart memory module, and hence these 2 outputs are synced up, so they activate at the same time, at the same sort of intervals. The second thing I'm going to explain is, of course, the spaghetti wiring. So this is our input, and it powers down to here. It unlocks this hopper momentarily, letting the first item through. And it also heads over here to power the minecart memory modules. Then it comes up here where it pulses this item into here. So this is an RS NOR latch. And then that turns the 8 game tick clock on. So that will start these droppers pulsing, and that will send the item across. And that is just to make sure that it's in sync with this over here. So these are now in sync, and the item travels across. And then when it gets into a sorter, it of course powers this line, which then powers up to this XOR gate that we had earlier. So then this XOR gate compares the input from the sorters to the input from the minecart memory modules, and if they match, then it doesn't trigger, but if they don't match, then it triggers, which means that the output is no longer true. So I'll give you an example at the moment, but yeah, of course I've actually built up 4 of these. I've realized I've actually built it in the wrong orientation. So technically I should have built these facing east-west, and I've built it facing north-south. So I need to rotate these, but I'm going to rebuild the whole contraption one final time anyway, because I'm going to compact it down and then add in the inputs. Because I want to try and make it programmable. I'm not sure that I'm going to be able to, but even so, I do want to compact this down because I know it can be done, and I really want to do that. So I've filled in these 2. I had to leave out these ones in the centers in between them, because otherwise the minecarts would collide, which is why you're supposed to have it facing the other direction so they don't collide. But I've got the different codes in here, so I've got 1 3 4 2 in this one, and I've got 1 3 4 2 in this one. Oh no, wait, I've got 1 3 4 2 in this one, and 1 3 4 1 in this one. So the number of items is how long the delay is between. So if we actually trigger it, so I'm going to grab this hopper, which I've pre-filled with the correct amount of items, and of course I've broken away this dropper here, so let's do that now. You can see 1 3 4 2, and when we trigger this circuit, we of course get this game tick clock pulsing, and our lines pulse, and we get all of these pushed across, apart from the one which matches to the code. And then we can simply press this reset button, and it will trigger that lamp there, which is the only one that is lit. And then, of course, turns off this clock. So, ideally, the next thing I want to do is add in a pulse extender, which needs to be around 40-45 game ticks. And that pulse extender will trigger after the circuit's been pressed, and that will power this reset line after a certain amount of time. And that time is the maximum time that it would take a code to process, which would, of course, be 9999. 4 nines because they're the longest delay in our memory modules. So I'm going to sort of rebuild this rotated slightly, and I'm also going to try and compact down all of the spaghetti wiring to hopefully make it simpler and more practical, and then I'll cut back to you once I've done that. Dun 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 dun! The system is compacted. So as you can see, I have significantly decreased the size. So this is kind of the minimum size it can really be, because we've got the modules here, which I've made 4 of, and then we've got the sorters here, and there's only actually one space. Well, no, there's one space in here that isn't the sorter, which is where I've run the wiring, and one space here with the hopper, and everything else obviously has to be there. So this is really the smallest the system's going to get. And the next thing to do is actually to install the module that selects the 4 items to put in this hopper from an input panel. So obviously I've got the reset button, so first I'll demonstrate that it works, and then start work on this panel. So I'll go over a quick explanation again, because I'm not sure how clear it was in the previous clips, and this should hopefully clear it up. So we're going to have our 4 items in this hopper, like so, which is going to be leading into this dropper. When we press the button, one item is going to go into the dropper, and it's going to be in this dropper line, which is facing in this direction. Then we're also going to trigger these minecart memory modules at the same time, and these modules are effectively full of items, which creates an output through this hopper. So they travel from these minecarts will be swapped, so the top one will be on the bottom, and the items will travel from the top minecart down to the bottom one. Whenever a non-stackable item travels through this hopper, we'll get an output through this line, and whenever there's not a non-stackable item, so just a regular item, we'll have no output through this line. So this effectively creates a series of pulses that happen at specific intervals depending on the items in the memory modules. We also have, from the sorter, we power at the start this gate here, and that starts an 8-tick game tick clock, which is the same speed as this hopper transfer rate. And that allows these items to travel across these droppers. We're using the droppers because they're more consistent than hoppers. Then we have item sorters below the droppers, and these item sorters will be synced up to these memory modules. So whenever an item sorter triggers, we get an output through this line here, and this line is redirected into these repeaters here. So what should happen is in the correct module, so in the module where the minecart memory module matches the code inputted, this top line here and this bottom line here will activate at the same time. And in the incorrect modules, they activate at different times. In order to detect when it's a different time and when it's at the same time, we're using an XOR gate, which is what this massive thing here is. It's a series of XOR gates tiled, and these run into pistons here. So at the start, we'll have these blocks all pushed across on top of these observer blocks, and whenever the XOR gate gets an output so that items don't match, then we'll push the blocks across to here. And then at the very end, we have this reset line, which will trigger after a set amount of time, but of course I'm going to hook that timer up to the input panel so that there's a cooldown, so I haven't built that yet. And this button will simply be pressed, and that will send a pulse through here, so this will depower this clock, and then we've got a falling edge detector, so that will then, when that button is pressed, it will power through these observers, and if the block is present, we'll get an output through the lamp, and if it's not, we won't get an output through the lamp. So that's the basic premise of the system. Hopefully that explained it more clearly, and now I'm going to demonstrate it. So in here, we've got the first code in, which I've programmed in, and we're going to hit the button, and we should see that what we actually get is, after it's finished processing, of course, which I'll just wait a bit for, we can hit this button, and we'll see the first module light flashes. Okay, and now I'm going to test it with the second module. So I've got the code stored in this hopper for the second module, and I'm simply going to press the button now, and we should see that, of course, once we wait for the redstone to process for a bit. Okay, that should be good, I think. There we go. We can hit the button, and you actually see that this time the second module pulses. So we can effectively store an infinite amount of codes as long as we plan on building this. So this module can store up to 4 different unique codes so far. So now it's time for the input. So this is the circuit that I've installed that inserts 4 items into this hopper. So you'd think it would be simple, you just simply sort of throw your items onto the hopper. But of course, that's not going to work, because if you think about it, this hopper's always locked by this torch beneath. So you might think, let's just have a second hopper inserting into that hopper. And that's what I've done. But of course, we don't want to have it just insert, because we need to be able to detect when there's 4 items in the hopper. And this hopper can't have more than 4 items in, because otherwise they're going to get processed. So what we actually have is a comparator output from this hopper here, which has 42 items in, so that when 4 items are inserted into this hopper, we reach a signal strength of 3. And as you can see, then the 4 items are extracted and put into this hopper. And that is done by using this little circuit here. So we have this furnace here with a comparator output. So this is a signal strength of 3, subtracting from our signal strength coming from this hopper. So it will only transport through when the signal strength is 3, or there are 42 plus 4 items in this hopper. So this will pass the signal strength through to this little pulse extender, which then triggers through this block here into this torch and unlocks this hopper temporarily, just enough time for 4 items to travel out. And it's really that simple. So now all we need to do is find out a way of actually inserting our 4 items onto this hopper. And of course we're going to need another hopper actually inserting items into here. So I guess we'll just have it like this. So we can have our items here, 1, 2, 3, 4, and then when we do that, our items should travel through into here in batches of 4. And actually, that's also coincidentally what's going to trigger our system. So once the 4th item is inserted, our system is going to trigger. And now I've installed another circuit on top of that one that's a failsafe to prevent the system from breaking. So of course, if we were to insert 5 items into the hopper, we'd get 4 in here, so it would trigger, but then the first item would leave, the 5th item would come into the first slot, and then that would be transferred into this hopper, rather than the 2nd, 3rd, 4th, and 5th. The items in this hopper would take priority. So we need to actually lock that hopper. So I've moved the hopper from the top to the side so that this hopper does not suck items out from it. And it's currently locked. So to trigger the circuit, what we actually do is we press this button. So this will be hooked up to our reset line. So that's the same line as this button here. And that will occur when the system has finished processing. So then what we can do is we can insert as many items as we want into here, and it will only accept the first 4 and put them into here, because this hopper will be locked. And then when we want the next 4, we can press this button, and the next 4 will filter through, and the rest will remain here. So this works really well, and this is simply because this powers this dropper, which inserts its item into this side, and then this comparator locks this hopper. So it really is that simple. And then when we want to activate the circuit again, we simply push the item away out of this dropper, so this hopper unlocks. And the system is ready for use again, so we get the next 4 items. So of course, this does mean you can actually sort of queue up combinations. I don't think I'm going to put any work into preventing the user entering multiple combinations after one another, because this circuit's only going to be triggered. Probably going to have it actually triggered by the user as well. So we have an AND gate, so that the circuit has to be triggered by the machine, so the machine has to go, I'm finished processing, and then the user has to go, I'm ready to insert the next combination. So that will prevent the issue. We're going to move on to the next stage, which is actually going to be inserting the 4 items into this hopper. I've got a couple of ways to do this. So obviously, one of the simplest ways is just to simply have a dropper or something here, which is the input panel, with 9 items stored within it, and then you can just queue over the ones that you want, and that will insert them into this hopper. Now this is a simple system, granted, but it would actually technically work for this system. The other thing I wanted to try was obviously a 9 button panel. You press the buttons, and every time a button is pressed, it dispenses that item and puts it on top of this hopper. Now of course, there is kind of the little issue that say the 1 button is closer to this hopper than the 9 button, because obviously they can't all be in the same location. We're going to have the issue that if you press the 9 button and then you press the 1 button before the 9 item has reached this hopper, the 1 item will actually come in first, so the combination order may actually be jumbled up. I'm not 100% sure how to fix this, other than adding a cooldown to when you can press the buttons and a little indicator lamp. I think that would allow the solution to be fixed, so that the items won't dispense unless the cooldown is done, and that's when the item is inserted into the hopper. I've reduced the number of lines that we still need to hook up down to 2. So we've got this line over here, which is the reset line, that's going to be hooked up to a clock, so that when the circuit triggers, after a certain delay, the circuit will turn off, and that just prevents this clock running around the clock, because that would A, cause lag, and B, mean that it was out of sync with the contraption the next time it's activated. The second input line is, of course, the activation line, and I'm going to hook that up to this circuit over here in a minute, so that when we've got our 4 items in this hopper, that is when the circuit triggers. So you may recognize this new circuitry I've installed. We've got the AND gate I was talking about. We've got another RS NOR latch, and I'll go through this in a second, but for now I'll just demonstrate it working. So what we do is we insert our 4 items as before. We get this comparator locking this hopper down here so that no more items can go into the system. We have our 4 items now in here, and this is when the activation line will be triggered. So the system now processes our request just like before, and we've just got to wait like before until the system is finished processing. You can see by these torches when they've all stopped blinking, which they're still doing, that is when the system is finished processing. So then the clock will trigger this button, and what this does is it activates our activation. So there we go, it's done. And what also this does, of course, turns off the clock using this RS NOR latch here. And the second thing it does is it triggers this RS NOR latch, which turns this torch off. So this is part of our AND gate, which means that this is the only output controlling this line here, which powers this dropper. And so what this means for us is that when we press this button, this item in this dropper will travel through into here, and that will allow the next combination to be entered, because of course the system will be reset. If we of course press this button when this torch is still active, or the system had not been reset, then nothing would happen because this torch would still be lit. So we press this button, and that allows the system to reset. So this is something the player will do manually. It's just to confirm that they're ready to insert the combination. So they'll do that before they insert the combination to prime the system. And if they don't do that, then that's fine, because nothing will happen. The other thing is, if we want to remove this circuit, we can. This is 100% not necessary. It just prevents the player from queuing up combinations. So they could simply insert hundreds and hundreds and hundreds really quickly, and then AFK the contraption, which for a bank system isn't secure. But if this was to be used in any other application, this multi-combination lock system, it would be perfectly fine. So I'm going to actually reinstall this circuit now, and explain to you one last aspect of the circuit, which is simply the fact that this line from the AND gate triggers here, which sends this item in this RS NOR latch back into here, so that this side of the AND gate is powered again, and it has to wait until this button is pressed the reset line. Now I'm going to simply hook up the activation line, add a clock, hook up the reset line, and we should be done with this contraption. The outputs have been connected up, so the bank system is actually fully operational now. And of course I haven't hooked up any of the actual bank vaults. I think I'm going to leave that for another day. I'll probably create a second episode of this where I hook up a bunch of little vaults or send some minecarts towards the player or something. And I also want to make a better selection panel. I'm going to try and use my selection panel that I made in the Better Sahara video, improve it so it's faster, because we don't need to have a unique menu every time. We just need to have the same numbers, and I just want to have one of these, 2, 3 in each time that you select. So that's what I want to try and create. And as you can see, yep, I've made a bunch of banners with the numbers on, and I've also named them. So this is sort of the simplest way you can select. I am also going to try and make a selection panel in today's video, but in the second part of this creation video, which I'm planning on creating, I want to make the bank vaults, and I also want to improve the selection panel. Would you look at that? I've gone ahead and built up a button panel. So each of these buttons triggers a dispenser with the correct item in, and that goes into this dropper line. And this is an instant dropper line, so that also powers this rail, which powers with 2 ticks of delay all of these droppers. And because of the Redstone update order, it's an instant dropper line, and the items end up here. So the only time the system would ever break is if you activated these 2 buttons within 2 redstone ticks or 2 milliseconds of one another, which is a really small amount of time. And that's only if it was 2 that are like either side of each other. So if you went 1, 2, then it'll break. If you went 2, 1, it wouldn't actually break. So yeah, it's really great. So we're going to try these 3 combinations, which correspond to the first 3 modules. And of course you can expand this as far as you want, but I'm just doing it with 3 for now. Every 15 you would of course need to leave a gap, and add some extra delay and stuff in between the modules activating. So you'll need another 1 tick of delay in between the modules, and then you need a repeater that extends this line here every 15 modules, but I doubt you're going to need more than 15, and if you are, it's very simple to expand. So now for the demonstration, I'm first going to enter 1, 3, 4, 2, so these are 3 of the combinations in the cells over there out of the possible 4. So we're first going to enter 1, 3, 4, 2, so we're going to go 1, we're going to go 3, we're going to go 4, and we're going to go 2, just like that. And then the system should start automatically processing the number, and of course the processing light comes on, so I've just added some signs since the last take showing that lit equals processing and telling you to enter 4 numbers. And once this has done, we should see that our first lamp lights. And I'm not sure I've actually explained it, but here, instead of a timer, we've actually got a pulse counter, so it counts 45 pulses. Occasionally it counts 44, and occasionally it counts 43. It just depends sort of how it goes, but we only actually need 40 items, so I've added some extra just as a little buffer. So that's 10 items per, so because it takes 9 ticks to get to the end, and then we of course need 1 for the stackable item. So that means that all these memory modules have finished processing, and also all of the items have traveled through. And this is with the longest combination, which is 9999. So that would take the longest amount of time to process. But since we've got that sort of counter, it always takes the same amount of time. And talking of 9999, I've also installed this into the system. So let's try it. 9999. And we shall see the system process once again. So I'm just going to speed this clip up from now. And you can see that the third module does indeed light. So now let's move on to the third and final module, which is the second module, which is 3971. So let's go 3971. And I assume you're getting the gist of it by now. The processing lamp comes on, and our combination is entered. So let's watch once again and see it in action. So it turns out that that didn't actually work, because I actually programmed 8 instead of 9 into the system by accident. So let's make that a 9. And all we need to do now is enter the code once again. So that would be 3971. So let's do it. 397 and 1. And the system should start processing. And hopefully everything will be fine this time. And of course, that was just a mistake with programming. That was nothing to do with the actual redstone. So you're just going to double check the programming every time. You may notice I actually removed the button because I don't think it's 100% necessary. I think it's much smoother that it automatically starts processing. And of course, I will have another video coming out, hopefully in the future, a part 2 to this contraption, if you will. I'm going to leave it a couple of days before I start recording it and start working on it. So it may be quite a while before it comes out because, of course, videos do take quite a while, and I've been working on this for quite a while, this project here. So if you enjoyed, hit a like because it does really mean a lot to me. And if you really enjoyed, remember to subscribe. But yeah, that's this contraption. The second video is, of course, going to have better combinations. And I'm also actually going to build up the bank system, which sends your items to you or sends you to a vault or something like that. Because at the moment, all we're getting is a simple redstone output here, which is all great. And that is kind of what the combination lock itself does. But we still need to make it into an official bank to add some more redstone. So if you enjoyed, remember to leave a like, comment and subscribe down below. My name's been Vortex Warp, and this video has sadly come to an end. Goodbye guys, see you in the next one.